Here's our objectives for 3.7 though, putting it all together. So order of operations usually is what's going to happen when it says put it all together. With integers, so negatives and positives, I can solve integer word problems. So word problems, which we've done pretty good with. We've seen some already. And then the pattern thing as well, which we've seen, but in the last module when we did it was with fractions. So you kind of had to look at the numerator and denominator separately. No fractions in any of the stuff that I saw today. So. Order of operations, parentheses. So you got to find any set of parentheses, and this isn't formally in parentheses, but we treat it like a set of parentheses in math, where we say, if you see a fraction like this with stuff on the top and then stuff on the bottom, you have to do the stuff on the top and the bottom separately. And then at the very end, then you would treat this like a divide sign. After parentheses, after we've evaluated, we've seen these as well by the way, these absolute values, which we will see again today. And then exponents, which we saw a little bit of that last time. I think that was a good review. And then remember this part right here, it's multiplication or division from left to right. So it's not always going to be multiplication first. Sometimes your division comes first if it happens further to the left. And the same is true for addition or subtraction from left to right. And so we've seen this whole slide we've seen before. It's not always PEMDAS. The M and the D can switch places, and then the A and the S as well. So just with the numbers we chose, 5 times -6 minus 32 divided by -4. Now, one of the problems with a problem like this is that students will look at this and do it strictly from left to right, because like we saw, you do multiplication or division from left to right, and then you do addition or subtraction from left to right. And it's like, oh, it's always left to right, which isn't true. It's an order thing, right? Order of operations. So if we do this out of order, and this is the way I like to look at it, it's like doing surgery. If you do surgery out of order, not that I've ever done surgery, but I would assume if they did surgery out of order, then things would get pretty jacked up, right? Probably. Like you don't want a doctor to do the surgery and then wash their hands for the first time. Right. Or in the middle of the surgery, give you the anesthesia. You know what I'm saying? I would not want that at all. No. So it's kind of the same thing with the math problem. We got to make sure that we're operating correctly on these so we can be math surgeons. How about that? Yeah. Sure. So this one, it does have parentheses, but there's nothing to do inside the parentheses, so we can skip the parentheses part. Really, the parentheses are just meant to show that we have negatives. Okay. Oh, okay. So that's good. There are no exponents, so we can move straight into the multiplication. Okay, so the multiplication, 5 times -6, boom. So first off, the sign, right? Negative times positive, positive times a negative. Opposite signs, however you want to look at it. This answer will be a negative. And then we can do 5 times 6, just regular, which is 30. So that's going to be -30. We're going to drop everything else down. Now again, the order of operations, the beautiful part about that is that we were ignoring this part completely. We didn't have to worry about it. We didn't have to look at it. We didn't have to think about it. Right. And then we just drop it down once we finish that one operation. Now we'll go to the next operation. And again, one mistake we see is that students will do this part right here. -30 minus -32, -62. No, we do not want that either. We're still on multiplication or division from left to right, and we have this division. Now again, with the division right here, we are ignoring the -30 part right there. Just completely ignore it. And I would look at 32 divided by -4. Later on, by the way, I would treat this as -32, but we're not going to do that yet. But you can. So 32, we're going to treat this as 32 divided by -4. Again, there's a positive divided by a negative. Only one negative, which is odd, so our answer is a negative, or they're opposites, or there's positive and negative, whatever. So I know my answer is going to be negative. 32 divided by 4 then would be 8. Now my new problem, after working with just that one operation, is -30 minus, and I'll put the -8 in parentheses, just so we know it's not minus minus or negative or something funky like that. -30 minus -8. So let's put that in. The minus the negative. Yeah, you're good. The minus the negative is going to make this a plus sign. 2 negatives make a positive, however you want to look at that. Good. So now we look at these two. We're adding opposites. One's negative, one's positive. We're adding, not multiplying or dividing like we were before. And as we combine these, I see there's more negatives than positives to combine. They are opposites, so I take the big number and subtract the small one. 30 minus 8, make that 22. So finally, that was our last operation, and that completes the problem. I'm going to go back there on this part. So let's go to this second question here. And think about it like this. So we still are going to ignore this time the negative 30. Just don't worry about that. If you look at it as is right there, this would be negative 30 divided by negative 4. Negative 32 divided by negative 4. And now when I combine these, I would say first the sign, right? I have a negative divided by negative. Two negatives will make a positive. I'm going to put the positive sign because it will become an operation. Yeah. And 32 divided by 4 then would be 8. See, now when I look at the negative 30 down here, it kind of gives me the ability to skip this part right here where I had the minus negative thing, and it just automatically became the plus sign.
Okay.
All right, so the order of operations, I would go through here. There is parentheses, but the parentheses are just to communicate that that value specifically is negative. No operations to do on the inside. So we would look then for exponents. There are none, which means we can go straight into multiplication or division. There is some multiplication, but there is a division here first. So that is what we will do first. That is negative 12 divided by 4. So only one negative, so the answer will be a negative. 12 divided by 4 is 3. So it ends up being just negative 3 on that part. We'll drop everything else. Okay, so there's the division. Still on multiplication or division, and we need to because it's not showing the multiplication sign, but there is one there. So we'd have to multiply that 3 times negative 5, only one negative, which makes our answer a negative. 3 times 5 is 15. So that's going to be negative 15. Now we have. Now again, the parentheses there, both in red and purple, are just meant to maintain the negativity of those values. So that's all of our multiplication and division. So we're now on addition or subtraction from left to right. There's only addition, and these are all negatives. So when I start here on the left, just between these two, it's a negative 7 and negative 3, so the answer will be negative, just more negative, which means we're going to take the two values and add them. So 7 plus 3 is 10. So that's going to be negative 10 plus negative 15. And these two as well, two negatives added together makes something just more negative, which means we're going to take the two values, 10 and 15, add these together, boom, 25, negative 25, done. Got some absolute values on this one, and there are absolute values with stuff to do on the inside. So let's ignore the negative 9 and the minus 8 to the power of 2. There is an exponent on this one too, so we'll have to keep that in mind. Okay, so that negative 9 and the minus 8 to the power of 2, they're still there, we just don't have to look at it. And let's just focus on working on the inside of this absolute value. So inside the absolute value, are there any parentheses? As it turns out, there is. So that's the first thing we are going to have to do. These are both positive values, 7 plus 9, which is, you can just use your fingers to count that. That's going to be 16, and I'm going to keep that in parentheses. Okay, so this is the rest, and I'm pretty much ignoring the absolute values as well at this time, although I'll bring them into the expression later. So we did parentheses. There's no exponents in the absolute value, but there is multiplication right here. So I'll have to stack and multiply that because I do not have my 5 multiplication tables memorized up to 16. So I do 5 times 6 first, which is 30, carry the 3. 5 times 1 is 5, but adding the 3 would make that 80. So we now have 80 from the multiplication, and now on the inside of our absolute value, we have negative 2 plus 80, which we will combine. Yeah, so that's going to be 78 there. Now, that is all the operations on the inside of those absolute values, which is now, it now means that I want the absolute values. The absolute value is just saying how far away is that value from 0. So how far away is 78 from 0? It's 78. Now that 78 does not have a absolute value anymore, we can make it parentheses if we'd like, And since we've completed all the operations with the absolute value, now we should look on the outside. And we want to look at that -9 with this times this 78 there, and then minus 8 to the power of 2. Okay, now again, instinctively, a lot of students will just do this multiplication first, which actually in this case you can get away with because of the minus sign right there. But we're going to ignore it and do this in actual order of operations, which means that I would look at the 8 to the power of 2, which is really just 8 times 8, and 8 times 8 is 64. Okay, so that's the exponent, and now multiplication or division from left to right. Yep, we got some of that. So negative 9 times 78. First, our sign is the negative times a positive, which will be a negative. And then we'll have to do the work here on the left. 78 times 9. So 8 times 9 is going to be 72. Carry the 7. 9 times 7 is 63. But adding the 7 going to be almost, should be 70. In my mind, I'm doing that wrong. Hold on. Thank you. It is 702 then. Now we have 702 minus the 64. And yeah, this is just subtraction at this point. Which, if you wanted to change this to addition, that's fine. But a lot of people like this, to look at this as being like, you know, you owe $702, then you're going to spend another 64 bucks. And if you do that, that will put you further in debt. So we know you'll be in debt and have a negative value, which means you take the 702 in debt and add another 64 in debt. 2 plus 4 is 6. 0 plus 6 is 6. 7, just drop it. 766.
I forgot to drop the...
All right, so parentheses. I'm doing the one on the left just because I go from left to right.
Yeah.
But we're focused on the parentheses, not the 5. So negative 7 plus 1, there's more negatives than positives. That's going to make the answer negative. 7 minus 1, since they're opposites, wouldn't be 6. That's going to be negative 6 right there. Now again, some students, and you can do this since the two parts are separated by this addition sign. Some students like to do this part right now. I'm just going to rewrite the whole thing though. Okay, now I will focus on this other set of parentheses. Negative 6 plus 9. Again, they are opposites, but now there's more positives than negatives, so the answer will be a positive. I'm not going to put the sign. Then I do 9 minus 6, which is 3. Okay, so this part is 3, and then everything else just stays the way it is, right there. Okay, that's all the parentheses that we have. No exponents, but we do have 2 sets of multiplication. And again, it doesn't really matter which one you do first because it's separated by the addition sign, but I'm going to do this properly from left to right. Here's my multiplication. 5 times negative 6. There's only one negative, which is odd, so the answer is a negative. 5 times 6 is 30, so negative 30. And again, I'll just drop everything else there. We're gonna add this 9 times 3, and we would have to do the 9 times 3 next. Again, please never do the negative 30 plus 9 right there, because it's out of order. 9 times 3, positive, is gonna be 27. So now we got negative 30 plus 27. And these, again, we're back to adding with negatives. They're opposites, and there's more negatives than positives, so the answer is a negative. And then you do 30 minus 27, because they're opposites. Really, it's just 10 minus 7, which is 3. Negative 3. We did it. All right, patterns. So this was part of the second part of the objective. So left to right or right to left, doesn't really matter. We tend to go left to right, so I don't know. I almost feel compelled to just cross that part out. Left to right is usually how we go, and then changes the operation. Yeah, that's fine, but again, we're going to focus just on going from left to right. Look at the numerators and denominators separately. We're not going to see any fractions, so as it turns out, we don't really need any of that garbage either. But we will look at the patterns that are just given with just the numbers that are given to us. What we need to understand, especially if I just, well, left to right or right to left, if the numbers decrease, let's see if I can make this a little better. If the numbers decrease, here's what I would expect. Decrease. Then we will expect one of two operations, either division, because division will make numbers smaller, or subtraction, which may be a little bit more direct. So this means if the numbers increase instead, and we have to be careful, especially with negatives, right? Because if numbers are becoming more negative, so if they're increasing in negativity, they're actually getting smaller, so they're actually decreasing in value. So we would expect some form of usually subtraction there. But if they're increasing in value, then we will expect multiplication or division. There we go. List the next three numbers in this pattern. I don't know, 3 numbers is overkill, but that's what they want. Fair enough. All right, what I notice on these is that to get from 38 to 32, because I'm going from left to right, 38 to 32 to 26 to 20, these are all going down in value. They're decreasing in value. So I would expect either division or subtraction. The good news is that it's not very easy to divide 38 by something to get 32. Why is that nice? Because that means it should be subtraction. So I would look at this and say, well, what would I have to subtract from 38 to get 32? And as it turns out, we can just use a fact family there. Just take 38 minus 32, and that will tell you the difference between those two numbers. 6, boom. So yes, 38 minus 6 will give you 32. Now, if this is a pattern, then I would be able to do 32 minus 6 to get 26, and it is. That's good. Actually, that should confirm the pattern, but we can continue confirming. 26 minus 6 is 20, yes. So the next number would be 20 minus 6, which is 14. And just continuing to the next two values, would do 14 minus 6, 13, 12, 11, 10, 9, 8. All right, ran out of fingers there. There we go, 8. And then 8 minus 6, 2. Bam. Okay, so minus 6, minus 6, minus 6. You just keep minusing 6. Get these other 3 numbers. Just as a theoretical, if these were negatives, the only things, like if this was negative 38, negative 32, negative 26, negative 20, the only thing that would change is this would be plus 6 instead. It's because you'd have smaller negatives, which means you'd have increasing value. Okay, translating operations and, well, equations is fine, but we're just going to be writing out the expressions for these. Let's see, the asterisk ones are important for us. Addition and multiplication order does not matter because of the commutative property of multiplication and addition, but subtraction and division have no such properties, which means we do have to be very careful with order. And so, if we see less than, we know that it will change order. So if I were to theoretically put some numbers in here and say it's 5 less than 10, okay, this would be the same as 10 minus 5 because it will change the order there. This 5 less than 10 is the same reading as this, although we would usually read this as 10 minus 5. Same difference. Or subtracted from, if I did 3 subtracted from 4, then you'd have to start with the 4 and subtract from it the 3. So again, the order changes with those. And then with division as well, divided into, we'll switch the order. So if I said 2 divided into 10, then you would have 10, and you're going to divide it by 2, like this. Now, equating is equals the same as total sum of difference of. Yeah, these are all like the answers to addition, subtraction, division, multiplication, but is usually the one that's used. So they may say 5 less than 10 is 2. Okay. Is would be your equal sign on that. You have $60 in your checking account. You write a check for $100 and deposit a check for $600. Write a symbolic expression that represents this problem and then figure out the new balance. The first thing we're going to do here, write a symbolic expression, which you're going to have to do on the assignment as well. Let's start with just what we have. So you have the $60, meaning you're in the positives there. That's nice.
Yeah.
Now you're going to write a check write a check for $100. So there's a couple different ways to do this. With the 60, you can just say, I'm gonna take that $100 away, minus. Some students would say plus a negative 100. I'm just gonna keep it as minus, just because it's less writing, and I am that lazy. Next up, we're going to deposit a check. Deposit would be adding money to the account, and it says it's $600. So this is our expression. I believe on the assignment, it would still accept a plus a negative 100 in parentheses right there. So both will work. Now that's our expression. So since that is the expression, what is our new balance? Well, first we'll do 60 minus 100, or 60 plus negative 100. So if I just keep this as minus, I would look at this as we're taking away more than what we have to start with, which means that I should end up in the negatives just from that part. And then, since we're going to the negatives, I can take the big number and subtract the small number and get 40. So after writing that check for $100, I would be owing the bank $40 right there, but thank goodness we put in a $600 check after that, which is gonna put us in the positives. So right here, I'm adding more negatives than positives, which means my answer should be a positive. And then they're opposite signs, so I would take the big number and subtract the small number. So 0 minus 0, 0. You can make that 10 minus 4, which is 6. Drop the 5. So your new balance is 560. Never forget to label this, especially on an exam or test or quiz or whatever, dollars. And so that's the first box, that's the second box. You grow artichokes in your garden. Last year you grew 6 pounds of artichokes. This year you grow 13 times last year's amount plus an additional 10 pounds. Write a symbolic expression that represents this problem. And how many pounds of artichokes did you grow this year? Look, let's make our symbolic expression right here. So yeah, we did grow 6 pounds of artichokes last year. This year it's 13 times that amount. So I'm going to take that 13 right there, and we're going to have to multiply it by the 6 pounds. So, because that's what we grew last year. So 13 first times the 6. I'm just going to show times 6. You can put it in parentheses if you'd like. But then it says in addition to that, so plus, we're going to put in another 10 pounds in there. So plus 10. Bam. So this becomes our order of operations, and we must do the multiplication first, which is 13 times 6, which would be 78. And then we will add the 10, which when we combine these, we get 88. Never to forget the label, pounds. 1 box, 2 boxes, that's it. Now, I'm going to point this out right here. Mathematically speaking, it's the order of operations is kind of ridiculous. Because even on a problem like this one, I don't know a lot of people that would be like, oh, 13 times 6 and then plus 10, writing an expression like this. I can see people doing 13 times 6 first. Okay, 13 times 6 first, they'd get the 78, and then separately, they wouldn't write this, but they would then add the 10 on paper or something else, and then they would get the 88 pounds. So I guess my point is the order of operations, to me, it just makes a lot more sense in a word problem like this than it does to just say, hey, solve this right here.
Yeah.
It's like, well, give me some context.
Right.
And the context itself usually takes care of itself. So as it turns out, people do use the order of operations all the time.
Yeah.
They just don't use it formally in this
Yeah.
way.